So this video is on total and net ionic equations. It's actually a pretty straightforward video. We've already sort of looked at these types of equations without actually recognizing them as total and net ionic equations. So we'll start off with our definitions and then we'll do some examples, and this video should not be very long. So here are your three definitions. So your first blank, your total ionic equation is a list of all the ions that form the chemical equation. A net ionic equation, your second blank there, is a list of the ions that actually took part in the chemical reaction, or for more clarity there, they actually made up the precipitate. And then the last one are spectator ions. Spectator ions are all of the ions that are not actually involved in the reaction that produces a precipitate. So basically, those ions just end up floating around doing nothing. So let's look at some examples now. Here is, again here, you know what, I'll just get this up here so you can focus a little bit more. So here is an equation that you probably remember from Unit 2. So I've got copper sulfate and sodium chloride gives me copper chloride and sodium sulfate. If you look up on your solubility chart, you'll see that my reactants are both aqueous, and my products, my copper 1 chloride over here produces a solid. And then I also have sodium sulfate as part of my aqueous solution. So here's what it sort of looks like. If I do this, or maybe not. Here are my solutions here. So when copper 2 sulfate is aqueous, remember that aqueous means it's dissolved in water. So my ions are actually split apart. My sodium chloride is also aqueous, okay, so again, my ions are split apart. So I've got positive ions and negative ions, and they're all split apart and they're all dissolved in solution. That's what aqueous means. When I mix these two beakers together, what I end up with is I still have sodium ions. I'll move that down a little bit more. I still have sodium ions, and I still have sulfate ions, okay, so that's my sodium sulfate. That's aqueous, and again, those ions are just sort of floating around in solution all on their own. But I also end up with a precipitate at the bottom of my beaker, and that's my copper 1 chloride, okay? And the reason why it's solid is because these ions actually end up sticking together and forming my solid. I actually have another animation to show you guys on this. Let's see if I can find it here. This one. So here is another reaction. This one is lead nitrate and potassium iodide, and I've shown you this one actually in class. But when we first mix them together, watch what happens. Sorry. So here's my resolution. So right now you can see all of my ions are floating around, but eventually what's going to happen is right here, there you go, one PB and two I's are going to come together to make a solid. Another one's going to happen here, there, and another one's going to happen here. But you'll see the potassium and the nitrate ions never come together to make a solid. So when we write out our equation for the double displacement, we know, we can look up on our solubility chart to know that our lead iodide will be solid. So there's my yellow lead iodide on the bottom here, and I write solid up in the reaction. But I also have potassium ions and nitrate ions floating around in solution, so I write KNO3 as aqueous to symbolize that those ions are not attached together, they're floating around. So to go back now, that's basically what happened in this reaction. So now what we have to do is write out our total ionic equation, our net ionic equation, and our spectator ions for this. So I'll just take this off. I'm going to scroll down a little bit. So my total ionic equation is, like the definition said, all of the ions that are happening in the reaction. So in this case, what you do is anything that's aqueous, you break it up into its ions. So Cu2SO4 means that there's 2 copper ions and 1 sulfate ion. I also have sodium chloride, so I've got an NaCl. Oops, sorry, not an NaCl. I've got an Na plus ion and a Cl minus ion. So those are my reactants, okay? And that's basically what's here. Now, I did forget to do something over here. I did forget to balance my equation at the start. My apologies for that. So I have to put a 2 there and a 2 there, which means in my total ionic equation, I have a 2 in front of my sodium ion and a 2 in front of my chloride ion. Then I'm going to write out the products. I'll do the products, say, in blue, and I'm just going to do them underneath because I am running out of room. So if you look, like I said, you split up anything that's aqueous, but my copper 1 chloride is still solid, so I'm just going to write that as a solid. But I also, again, have 2 sodium ions. That's aqueous. And 1 sulfate ion, SO4 2 minus, and that's aqueous. That is your total ionic equation. I take everything from up here that's aqueous and I split it up into its ions. And I use coefficients instead of subscripts. Now if I scroll down a little bit further and I do my net ionic equation, basically to find the net ionic equation, I'm going to cancel out the ions that are on both sides of my reaction. So in this case, I've got 2 Na on my reactant side and 2 Na on my product side. And I've got SO4 on my reactant side and SO4 on my product side, so those ones cancel out. And my net ionic equation ends up being only the ions that make the precipitate. So in this case, it would be 2 Cu2 plus. That's aqueous. I have 2 Cl minus. That's aqueous. And I make 2, oops, I forgot to put the 2 in front there. So that would make 2 copper chloride, which is solid. That's my net ionic equation. So anything that's left over and doesn't get canceled out, gets put in the net ionic equation. Or the 2 ions that make up the solid precipitate is what's in the net ionic equation. All right, and then if I scroll down just a little bit more here, spectator ions are the ones that you cross out. So they're not actually involved in the reaction, they're just kind of floating around in the reactants and they're floating around in the products. So my spectator ions in this case are my sodium ions and my sulfate ions. Okay, and I've got 2 sodium ions. So that's how you do total and net ionic equations, and that's how you figure out your spectator ions. So we've got a couple more examples to go through. I'm going to do, say, 2 more with you, and then I'll get you to do the last one on your own, and we'll take it up in class. So here is another one, lead nitrate and potassium iodide. So this was the one from the animation that I just showed you. So this is a double displacement reaction, so you have to be able to predict the products and figure out that you make PbI2 and you make KNO3. Don't forget to check your charges and crisscross, okay? And then you're going to go back and balance your equation. So I need a 2 in front of my KNO3 and a 2 in front of my Ki. And then the last thing I have to remember to do is check to see on my solubility chart if I make a precipitate. So when I check on my solubility chart, I see that PbI2 actually makes a solid, but KNO3 stays aqueous. So all of that should be a little bit of review from Unit 2. Balance, or predicting the products of your reaction, balancing it out, and telling me what all the states are. And you're going to get marks for all of those things in this unit as well. So your total ionic equation now, you take everything that's aqueous, so maybe I'll color code this a little bit for you. Take everything that's aqueous, so what I underlined in red, and you're going to split those ones up into their ions, because that's what actually happens in solution. So I've got Pb2 plus, and that's aqueous. Don't forget to put the states. I've got 2 NO3 minuses, and that's aqueous. And again, I have that 2 as a coefficient because of my 2 as a subscript here. I also have 2 K pluses that are aqueous, and 2 I minus that are aqueous. And that's my reactants. Okay, and the only thing I'm not going to break up, I'll do this in black. I'm going to leave my PbI2 as a solid. There's my solid. And then the last thing I break up is my K plus. So I've got 2 K pluses again. And I've got 2 NO3s again. Okay, so you're getting marked on, did you separate everything out properly? So did you separate out the ions from the aqueous compounds? Did you leave your lead iodide as a solid? And did you include the states for everything and your coefficients, put everything in so that everything is balanced? That's what you're going to get marked on for a total ionic equation. And for the net ionic equation, you basically cancel out your spectator ions. So in this case, I've got potassium on both sides as an ion, and I've got nitrate on both sides as an ion. So my net ionic equation ends up being Pb2 plus as aqueous, plus 2I minus, that's also aqueous, and that gives me my solid, which is Pbi2 solid. There's my net ionic equation. And then my spectator ions here would be the ones that I crossed out. So I have 2 positive potassium ions and 2 nitrate ions. And that's it. So as long as you understand to split up anything that's aqueous into its ions, and you keep anything that's solid as a solid, you're good to go. So we'll do one more example in this video, and then the last example that's in your notes. You guys try and do it at home on your own, and then you can check your answer during the Check Your Understanding with me. So here is ammonium sulfide and iron 2 sulfate. So our first job is to predict the products of the reaction. So I'm going to get FeS, and I'm going to get NH4 to SO4. Okay, and when I do this, my next step after this is to check to make sure that I've done all my crisscrossing properly, and I did that. So then next I got to go back and balance it, and actually this one's already balanced, so that's easy enough. So now what I have to do is figure out if I make a solid, if I make a precipitate. So if you check, anything with ammonia in it is usually aqueous. But iron sulfide will actually be a solid compound. So now I can write out my total ionic equation. So again, let's separate out, I'll do it in red. Everything that's aqueous has to be separated out into its ions. Everything that's solid stays just as it is. So let's write it out. So I start with 2 ammonium ions, they're aqueous. I also have a sulfide ion. That's aqueous. Now if I look at my FeSO4, I have an Fe2 plus ion. That's aqueous. And I've got a sulfate ion. That's aqueous. On my products, my FeS, my iron sulfide, has to stay together as a solid, so I don't break that up. But I can break up my ammonium sulfate. So I've got an NH4 plus, I've got 2 of them because of my subscript here, and I've got SO4 2 minus, that's aqueous. So now to write out the net ionic equation, I cancel out the ions that are present on both sides of my reaction. So NH4 gets canceled out, and SO4 2 minus gets canceled out. So those things that I cancel out end up being my spectator ions, so I can just skip ahead and write those in. So I've got 2 ammonium ions and an SO4 2 minus ion. Those are my spectator ions that just float around and basically don't do anything. And whatever's left over, so Fe2 plus, that's aqueous, and sulfur or a sulfide ion basically breaks apart and makes my solid. So that's how you do total ionic equations, net ionic equations, and figuring out your spectator ions. I'd like you guys to try the last example on your own from your notes and see what you get from that.